proof that the Goldbach's conjecture is true. With Goldbach's conjecture, some of the feedback has made it clear that some people are confused and do not actually understand exactly what needs to be proven, so perhaps are overcomplicating things. So in this video, I'll clarify what must be proven, followed by the absolute proof itself. The simple mathematical beauty is that we need to know nothing of the exact locations of individual primes. The conjecture is, prove that every even number x is the sum of two different prime numbers. It can be at least two, but it can be made of 2, 3, 4 or more pairs of primes. The conjecture is not seeking to prove whether we will run out of primes or whether the rate of decline of primes to integers will drop to zero. We know the density of primes to integers decreases steadily, halving with every doubling of integers, and follows the harmonic series. We know that the ratio of primes above and below half of x grows closer to 50-50 the higher the value of x. What must be proven to prove this conjecture is whether or not we will reach a point where all composites overlap with all primes, thereby blocking two primes from summing to x. That's the basis of the conjecture. That's it. The intuitive way, which at first seems must be the only way to solve this problem, is to try and figure out the sequence or location of primes to pinpoint where at least some primes must be located to prove whether or not such a block is possible. However, I realise there's a different way to solve it, which at first seems unintuitive but actually holds the key, and this is it. If we can eliminate all possible composite pairs with sum to x and composite prime pairs with sum to x, then if there are any odd numbers left, they can only be prime numbers and in pairs of locations with sum to x. And using this simple method of elimination, we find that no matter how many composites to primes there are, we can never eliminate all odd numbers, which means that those which are left must be primes and located in positions where they pair and sum to x. There is no other place for them to be, so a block of all primes summing to x by composites is impossible. So we will always get prime pairs summing to x, the number of which grows with slight insignificant fluctuations over relatively small ranges as the value of x goes towards infinity. So here's the proof with a visual chart to help make it clear, and just to remind everyone who is doubting that something so simple could have been missed by so many great minds for so long. One of the reasons it is so famous is that it seems like it should be easy, yet it has baffled even the best. And just because something is easy to understand after it had been figured out doesn't mean to say that it was easy to figure out, which in this case is evidenced by 300 years of history of people failing to notice this simple solution. It may be a shock and difficult to believe at first, perhaps, but the math is clear and indisputable. Let x be an even number. Every odd number under half of x pairs with an odd number above half of x to sum to x. An odd number never pairs with an even number, so we can eliminate all non-prime pairs using the sieve. So by doubling the primary sieve to remove all multiples of primes less than the square root of x and the odd number which they pair with and sum to make x, which is x divided by two odd numbers, less 2/3, less 2/5 of the remainder, less 2/7 of the remainder, less 2/11 of the remainder, etc. Eliminating 2 over every prime number from the remainder every time for every prime under the square root of x. So the only odd numbers remaining must be primes and in pairs of locations which sum to x. Because the number of primes increases steadily, only halving in density to non-prime integers with every doubling of integers, while the density of composites of any new highest prime below the square root of x always decreases, it means the gross of fractional reductions of pairs with one or two composites summed to x, being inversely proportional to the growth of new primes, can never catch up and eliminate all prime pairs with sum to x. So the Goldbach's conjecture is hereby proven absolutely true, with no need to know the location of individual primes. Thank you for watching, and please like and share, because I don't have the big money or powerful contacts to get this into the headlines. So I'm dependent on the kindness of people who love maths, truth and science to bump up the algorithm and get it to everyone else who also loves math, truth and science.